various type of functions. Various type of functions. Various type of functions. First part, algebraic functions. Various type of functions. First part, algebraic functions. Any function which is obtained, any function which is obtained, any function which is obtained by using algebraic operations, any function which is obtained by using algebraic operations. Example, addition, subtraction, multiplication, division, addition, subtraction, multiplication, division, square roots, square on x, square roots, squares on x is called as algebraic function. Is called as algebraic function. Example, y is equal to x raised to 1 by 2 plus x raised to 1 by 3. One more example, x raised to 3 plus 1 upon x square plus 9. Okay, take one more example is y is equal to x cube plus x square plus x plus 1. Y is equal to x cube plus x square plus x plus 1. Next point. Next point. If y is an algebraic function, if y is an algebraic function, if y is an algebraic function, then it will satisfy the algebraic equation. If y is an algebraic function, then it will satisfy an algebraic equation, an algebraic equation of the form P naught x, P naught x is a function, P naught x is the P naught of x into y raised to n plus P1 of x into y raised to n minus 1 plus dot 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 Pn of x into y raised to 0. In place of 0, write n minus n is equal to 0. So basically it's a function of y. P naught x is not nothing but a function of x. The function of x, y raised to n, this is a coefficient. P naught x is the coefficient. P1 x is the coefficient. So y raised to n, uske baad the next term will become y raised to n minus 1. Say for example, if I take y cube, it will become y square, then it will become y, and then it will become y raised to 0. So this is the function, P naught x into y raised to n, P1 x into y raised to n minus 1. This is the function. ये function है, and we write it in this manner. Please write this down. Where P naught x, comma P1 x, comma P2 x where p naught x comma p1x comma p2x dot 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 pnx where p naught x comma p1x comma p2x dot 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 pnx are functions of x which are called as polynomial functions of polynomial functions or constants which are called as polynomial functions or constants now a part write down a part. Okay, so under algebraic we'll be writing polynomial functions. Okay, a part polynomial functions. A part polynomial functions. A part polynomial functions. An expression of the type a naught plus a1x plus a2x square plus dot 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 anxn where n belongs to whole number, where ai belongs to real number, ai का मतलब होता है your I is basically 0, I is 1, I is 2 and I is n. So basically it will be real number. So I will become from 0, 1, 2, 3, 4 dot dot up till n. Okay, where n belongs to whole, ai belongs to R is called as, where n belongs to whole, ai belongs to R is called as a real polynomial. Is called as a real polynomial. Okay. Example: y is equal to x raised to minus 1 plus 4. Now they have said that n belongs to whole number, but minus 1 is not a whole number, and since minus 1 is not a whole number, this is an example where it is not a real polynomial. See, because if you check the definition, it's not a polynomial. देखो simple सी बात है, it's not a polynomial. Why it's not a polynomial? Because n does not belong to whole number, but the definition says that n has to belong to a whole number. X raised to minus 1 is not a whole number, and since minus 1 is not a whole number, this is not a polynomial. So if you go through the definition again, an expression of the type y is equal to a naught plus a1x plus a2x square plus dot dot anxn, where n belongs to whole number and ai belongs to real number, then and only then we can tell it is a polynomial. If you take an example where y is equal to x raised to minus 1 plus 4, since minus 1 is not a whole number, I repeat again, since minus 1 is not a whole number, therefore it is not a polynomial. Therefore n, because n does not belong to a whole number. Next, here an is the leading coefficient. An is the leading coefficient. Here an is the leading coefficient. Here an is the leading coefficient. A naught is constant term. an is the leading coefficient, a naught is the constant term, also known as a naught is the constant term, also known as absolute term, also known as absolute term. Y is equal to x raised to 5 plus x cube plus 5. This is an example. Now y is equal to x cube plus 5 plus x, y is equal to x raised to 5 plus x cube plus 5. Here, my leading coefficient is 1. See, this is a leading coefficient. My leading coefficient is 1. And a naught is basically a constant term. Here, my constant term, that is the absolute value, is 5. So, leading coefficient is equal to 1. And absolute value is equal to 5. Leading coefficient is equal to 1. Absolute value is equal to 5. Leading coefficient is equal to 1 and absolute value is equal to 5. Next point. Next point. A polynomial of degree 0 is called as a constant polynomial. A polynomial of degree 0 is called as constant polynomial. Example, y is equal to 5. A polynomial of degree 0 is called as constant polynomial. Example, y is equal to 5. Take one more example of your choice. We can take y is equal to 3 also. Okay, I have taken y is equal to 5, y is equal to 3. Except y is equal to 0. Except y is equal to 0. So we can take y is equal to 5 as a constant polynomial. We can take y is equal to 3 as a constant polynomial. We can't take y is equal to 0 as a constant polynomial. So y is equal to 0 is not a constant polynomial. Next point. A polynomial of degree 1 is called as linear polynomial. A polynomial of degree 1 is called as linear polynomial. A polynomial of degree 1 is called as linear polynomial. A polynomial of degree 1 is called as linear polynomial, which can be taken as y is equal to ax plus b. A polynomial of degree 1 is called as linear polynomial, which can be taken as y is equal to ax plus b. Where a is not equal to 0. Where a is not equal to 0. If b is equal to 0, where a is not equal to 0, if b is equal to 0, it is called as odd linear polynomial. If b is equal to 0, it is called as odd linear polynomial. If b is equal to 0, it is called as odd linear polynomial. It is called as odd linear polynomial. If b is equal to 0, it is called as odd linear polynomial. Next point. There are two polynomial functions. There are two polynomial functions there are two polynomial functions satisfying the relation there are two polynomial functions satisfying the relation f of x into f of 1 by x is equal to f of x plus f of 1 by x. F of x into f of 1 by x f of x into f of 1 by x is equal to f of x plus f of 1 by x. F of x into f of 1 by x is equal to f of x plus f of 1 by x. ठीक है, and it gives answer f of x is equal to 1 plus minus x raised to n. F of x is equal to 1 plus minus x raised to n, where guys n belongs to whole number. A very important thing that you need to remember. F of x is equal to 1 plus minus x raised to n. This is used when I get this relation. F of x into f of 1 by x is equal to f of x plus f of 1 by x, where f of x is equal to 1 plus minus x raised to n, where n belongs to whole number. Where n belongs to whole number. ठीक है, important point. Important point. Domain of all polynomial functions. Domain of all polynomial functions is x belongs to R. Domain of all polynomial functions is x belongs to R. Domain of all polynomial functions is x belongs to R. Next point, very important point. Next point, very important point. Range of odd degree polynomial function. Range of odd degree polynomial function. Range of odd degree polynomial function. Range of odd degree polynomial function is all real numbers. Is all real numbers. Range of odd degree polynomial function is all real numbers. And in case of even degree polynomial, the range is, and in case of even degree polynomial, the range is not all real. The range is not all real. Example. Y is equal to x cube plus 1. Domain matlab x values. Here I know that since it's an odd degree polynomial, my domain is going to be all real numbers. My domain is going to be all real numbers. Now range is something, see, it's all real numbers. Now for range, what we do is we convert everything in terms of y. Now how do I convert everything in terms of y? This will become x cube is equal to y minus 1. Therefore x will become y minus 1 the whole cube root. Basically cube root of y minus 1. Now if I take y ka any value, I'll be able to find the cube root, because cube root exists of negative numbers also. For example, minus 8 ka cube root is minus 2. Minus 2 times minus 2 times minus 2 will give you minus 8. So the cube root of minus 8 is minus 2. If I put any value of y, I take any positive value of y, I take any negative value of y, I take y ka value as 0. These are the three cases: positive value of y, negative value of y, and 0. If I take positive, negative or 0, I will still get an answer. And that is why the point that we wrote, that range of odd degree polynomial is all real numbers. तो देख के मालूम पड़ रहा है कि इसका range भी all real numbers रहेगा. The range is all real numbers because it is odd degree polynomial. Since it's an odd degree polynomial function, I understand that my domain is going to be all real numbers. My range, since cube root exists of negative numbers also, we know that the range is going to be R and the domain is going to be R for odd degree polynomial functions. But what will happen if I have even degree polynomial function? For example, if my question is x raised to 4, just write it here, y is equal to x raised to 4 plus x square plus 1. Y is equal to x raised to 4 plus x square plus 1. Even degree polynomial, if you see, for even degree, and in case of even degree polynomial function, my domain is not going to be changing. Domain matlab I can use any value of x. It means that my domain will be all real numbers. But guys, my range in the sense, if I put any value of x, any value, if I put positive value, if I put negative value, if I put 0 also for x, my answer, that is my y ka value that I get, that is going to be the range, and it is going to be from 0 to infinity. अब ये केस में 0 नहीं आएगा, कुछ भी ले लो 0 नहीं आएगा. My answer will be a positive number, and since my answer will be a positive number, it is going to be R plus. How do I now know that it is R plus? कुछ नहीं किया. If I put x का value as -1, -1 raised to 4 is 1, -1 square is 1, and 1. So 1 plus 1 plus 1 becomes 3. If I put y ka value, say for example, let's take a negative value. I have taken x ka value as -1. My y will become 1 plus 1 plus 1. So I have got a y ka value as a positive answer. I will take x ka value as 0. My y ka value that I have got, is going to be 1. And if I take x as positive 1, I'll still get 1 plus 1 plus 1, which is equal to 3. Under no circumstances, repeat again, under no circumstances will I get an answer that is going to be negative. For even degree polynomial, my range will never be negative. It will be from 0 to infinity, basically positive. अगर यहाँ पे सिर्फ 1 नहीं होता था, तो I would have got the answer from 0 to infinity. So my answer is going to be R plus, that is, my range is going to be from all positive integers, sorry, all positive real numbers. But मेरा आंसर कभी नेगेटिव होगा ही नहीं. तो remember this, for even degree polynomial, my answer will never be negative. My answer will never be negative. Has everybody understood this? Anybody has any doubts here? So remember this. For odd degree polynomial, my domain will be all real numbers, my range will be all real numbers. For even degree polynomial, my domain will not change, but my range will never have any negative value. My range will never have any negative value. Question. Let p of x be a polynomial function. Let p of x be a polynomial function. X raised to 6 plus ax raised to 5 plus bx raised to 4 plus cx cube plus dx square plus ex plus f, such that p of 1 is equal to 1, p of 2 is equal to 2, p of 3 is equal to 3, p of 4 is equal to 4, p of 5 is equal to 5, p of 6 is equal to 6. Find p of 7. Let p of x be a polynomial function such that x raised to 6 plus ax raised to 5 plus bx raised to 4 plus cx cube plus dx square plus ex plus f, such that p of 1 is equal to 1, p of 2 is equal to 2, p of 3 is equal to 3, p of 4 is equal to 4, p of 5 is equal to 5, and p of 6 is equal to 6. Find p of 7. Okay. Now, first of all, we have to find the relation. The relation is कि whatever term is given in here, you get the same term here. So, p of 1 is equal to 1. If x is 1, my answer is 1. P of 2 is equal to 2. If x is 2, my answer is 2. See this. If x is 1, my answer is 1. If x is 2, my answer is 2. If x is 3, my answer is 3. If x is 4, my answer is 4. If x is 5, my answer is 5. If x is 6, my answer is 6. If I combine everything, I get a relation that p of x is equal to x. So if I put, let's check if this satisfies. If I put x 1 here, so p of 1 will become 1. It satisfies here. If I put x 2 here, p of 2 is equal to 2. It satisfies here. If I put x ka value as 3, so p of 3 is equal to 3. It satisfies this condition and this condition and this condition and this condition. So now I have formed a relation saying that I can get p of 1 is equal to 1 only when x is equal to 1. It satisfies when x is equal to 2. In other words, p of x is equal to x for the first 6 conditions. 7th condition, I have to check whether this satisfies or not. Now, it is order 6. Whenever we write a quadratic equation, say for example, we always write a quadratic equation as a into x minus alpha, x minus beta. This is how we represented the quadratic equation, where a is your coefficient, your leading coefficient. It's always taken as 1. So here the thing is that I have the value of 6. There are 6 roots. Now since there are 6 roots given, guys, see, remember this, where we always write a quadratic equation on this form. Whenever a quadratic equation is given to you, say for example, if they tell me कि alpha and beta are the roots, we always write x minus alpha, x minus beta is equal to 0, where we always take this as 1. And we always write it like this, a into x minus alpha, x minus beta is equal to 0. This is how you represent a quadratic equation. But here we have 6 roots, and since there are 6 roots, what I am going to write it as, this entire equation, see, ax raised to 6 plus ax raised to 5 plus bx raised to 4, whatever it is, I have got this relation. This relation is nothing but px minus x is equal to 0. This relation is given as px minus x is equal to 0. And this relation, see how I am going to write it as, I will take the constant as k, and my roots are, see, these are the roots 1, 2, 3, 4, 5, 6. These are roots that are given to you. So I'll write k into x minus 1, x minus 2, x minus 3, x minus 4, x minus 5, x minus 6. Since these are the roots, 1, 2, 3, 4, 5, 6 are the roots of the equation, I can represent this equation in the form k into x minus 1, x minus 2, x minus 3, x minus 4, x minus 5, x minus 6. And it satisfies the condition. And if I combine both the equations together, I'll get p of x minus x is equal to k into x minus 1, x minus 2, x minus 3, x minus 4, x minus 5, x minus 6. Then I will write p of x is equal to k into x minus 1, x minus 2, x minus 3, x minus 4, x minus 5, x minus 6 plus x plus x. Now since k, I told you the leading coefficient here it's 1. Now the final value, if I put p of 7, this is 1. This will become 7 minus 1, 7 minus 2, 7 minus 3, 7 minus 4, 7 minus 5, 7 minus 6 plus 7, which will become 6 into 5 into 4 into 3 into 2 into 1 plus 7. 6 into 5 into 4 into 3 into 2 into 1 is 720 plus 1, which is 721. Plus 7, sorry. So this becomes 727. So this becomes 727. Now listen carefully. Let's check if I put x ka value as 1. If I put x ka value as 1 here, this entire term becomes 0 and I get 1. If I put x ka value as 1, so p of 1 will become, this entire term becomes 0. Why 0? Because 1 minus 1 is 0. 0 into all the terms is 0 plus 1. So p of 1 is equal to 1. It is satisfying. I'll put p ka value as 2. Second term becomes 0. If I put p ka value as 3, this term becomes 0. If I put p ka value as 4, this term becomes 0. Then the next term and then the last term. So it is satisfying all the condition. This is the most important part of the sum, where you have to form a relation. A relation can be anything. And how many roots are there? See, there are 1, 2, 6, 5, 4, 3, 2, 1. 6, 5, 4, 3, 2, 1. There are 6 roots. And as I told you, this is how we represent a quadratic equation. So 6th root equation will become x minus alpha beta gamma, but they have given the roots 1, 2, 3, 4, 5, 6 the roots there. And since they have given the roots, all we do is I'll write it as k into, and this is the leading coefficient, which is 1. यहाँ पे देखो, it is 1 here. So I know देख के मालूम पड़ रहा है कि k का value is 1, and since k का value is 1, that is given to me, all I have to do is, this is available to me. This is what I found out. P of x is equal to x. So P of x is equal to x. This is the equation. When I took equal to 0, this is the equation that is there, the quadratic 6th root equation. I equated both, and the last step what I did was I just put k ka value, x ka value as 7, and I got the answer as 727. Has everybody understood this? Remember this. This is the most important part of the sum, where you find a relation. P of x is equal to x raised to 6 plus ax raised to 5 plus bx raised to 4 plus cx cube plus dx square plus ex plus f. P of 1 is equal to 2. P of 2 is equal to 5. P of 3 is equal to 10. P of 4 is equal to 17. P of 5 is equal to 26. P of 6 is equal to 37. Find P of 10. Find P of 10. So this is the data that is given to me. P of 1, P of 2, P of 3, P of 4, P of 5, P of 6 is given to me. The first thing I understand is I have to find the relation between all this. So what is the relation? Can anyone tell me? P of x is equal to x square plus 1. Very good. P of x is equal to x square plus 1. P of x is equal to x square plus 1 is given to me. So in other words, I can write that P of x minus x square minus 1 is equal to 0. Coming back to this, P of x is nothing but k into x minus 1, x minus 2, x minus 3, x minus 4, x minus 5, x minus 6. Therefore, if I equate both the two, I will get P of x is equal to k into x minus 1, x minus 2, x minus 3, x minus 4, x minus 5, x minus 6 plus x square plus 1. The last step is I'll just put x ka value as 10. So this and k is 1. So 1 into 9, 8, 7, 6, 5, 4 plus 10 square plus 1. Multiply this and please tell me the final answer. Now, f of x, next question. F of x is a polynomial function. F of x is a polynomial function that satisfies f of x is a polynomial function that satisfies f of x into f of 1 by x is equal to f of x plus f of 1 by x. F of 3 is equal to 10. Sorry, f of 3 is equal to 28. Find f of 10. F of x is a polynomial function which satisfies f of x into f of 1 by x is equal to f of x plus f of 1 by x. F of 3 is equal to 28. Find f of 10. Okay. Now if you remember this relation, f of x into f of 1 by x is equal to f of x plus f of 1 by x. Whenever this relation is given to me, my answer becomes f of x is equal to 1 plus minus x raised to n. Now if I write like this, okay, say for example, if I approach like this, ki f of x is equal to 1 plus minus x raised to n, I'll write it in two parts. F of x is equal to 1 plus x raised to n and f of x is equal to 1 minus x raised to n. Now, f of 3 is 28. F of 3 is equal to 28, and if I substitute here, it will become 1 plus 3 raised to n is equal to 28. Therefore, 3 raised to n is equal to 27. 3 raised to n is equal to 3 cube. So n becomes 3. Okay, I've got n3. Let's check for that. Again, f of 3 is equal to 28. 1 minus 3 raised to n is equal to 28. Minus 3 raised to n is equal to 27. Now the problem is that I can't compare this because it's a negative value and a positive value. So this is not possible. Therefore, my equation becomes f of x is equal to 1 plus x cube. This is the function. And since I have got f of x is equal to 1 plus x cube, they have asked me the value of f of 10. So f of 10 becomes 1 plus 10 cube, which is 1 plus 1000. And my answer is 1001. This is the answer that is given to me. So I have used the relation f of x is equal to 1 plus minus x raised to n because this relation has been given to me. That is f of x into f of 1 by x is equal to f of x plus f of 1 by x. Please write this down. f of x is a polynomial function. F of x is a polynomial function satisfying f of x is a polynomial function satisfying f of x into f of y is equal to f of x plus f of y plus f of xy. F of x is a polynomial function satisfying this relation. F of x into f of y is equal to f of x plus f of y plus f of xy minus 2 for all. This is the symbol for all. This is the symbol for all. For all x belongs to real number. For all x belongs to real number. F of 3 is equal to 10. F of 4 is equal to question mark. F of x is a polynomial function satisfying the relation f of x into f of y is equal to f of x plus f of y plus f of xy minus 2 for all x belongs to R. F of 3 is equal to 10. I have to find f of 4. Now the first thing, this does not look like this relation. So there are two ways of doing it. Step number 1. What I can do is, where we do it into two parts, okay, where I start with case 1, where I'll take x and y both as 1. Try to understand. When I'll take x and y both as 1, so this will become f of 1 into f of 1 is equal to f of 1 plus f of 1 plus f of 1 minus 2, which becomes f of 1 the whole square is equal to thrice f of 1 minus 2, which is f of 1 the whole square minus 3 times f of 1 plus 2 is equal to 0. This has become a quadratic equation, which will become f of 1 minus 2, f of 1 minus 1 is equal to 0. अब इससे फायदा क्या हो? I have got values of x and these are the values of x कि या तो f of 1 is equal to 2 or f of 1 is equal to 1. So now it satisfies some condition that I have got two values कि f of 1 is equal to 2 and f of 1 is equal to 1. Okay, it's on the same lines कि I can say that, see, f of 1 is equal to 1 and f of 1 is equal to 2 is given to me. Depending on those lines, now you can get a good idea कि f of 3 is 10, f of 1 is 2, f of 1 becomes 2, so I can find a relation. F of 3 becomes 10, so I can find a relation. The relation can be anything. So this is the first part of the sum, okay, where I have got two values of x. We're not going to touch anything further. I've got two values of x, ki f of x value, I have got a quadratic equation ki f of 1 is equal to 1 and f of 1 is equal to 2. Now, depending on the scenario, if I take f of 1 is equal to 1, it does not satisfy this condition. F of 1 is equal to 1 is possible when f of x is equal to x. This is not f of x is equal to x. If f of x was x, f of 3 would become what? 3. Here f of 1 is equal to 1. So I am going to take, where I am going to take f of 1 is equal to 2 ka value, because f of 1 is equal to 1 is not satisfying the condition. Okay? As of now we are keeping this value. I'll just consider this value. This value we are going to consider. But for case 2, what we are going to do is, I have still not formed a condition here. It's not looking like this. I want it to look at least something like this because I have the formula. So what I am going to do is, I'll take y is equal to 1 upon x If I take y is equal to 1 upon x, this will become f of x into f of 1 by x is equal to f of x plus f of 1 by x plus f of 1 minus 2. Now I know that f of 1 ka value is 2. So this will become f of x into f of 1 by x is equal to f of x plus f of 1 by x plus 2 minus 2. And this has got eliminated. And now I have formed a relation. And the relation has become f of x is equal to 1 plus minus x raised to n. Now, if it is 1 plus minus x raised to n, again we are going to take two conditions. F of x is equal to 1 plus x raised to n and f of x is equal to 1 minus x raised to n. One value is given to me, f of 3 is equal to 10. So f of 3 is equal to 10. So 1 plus x raised to n is equal to 10. Guys, if 1 plus x raised to n is equal to 10, x raised to n becomes 9. Can you tell me what is value of n? So therefore, x raised to n is equal to 1 plus x raised to n is equal to 1 plus 3 raised to n. Sorry. 1 plus 3 raised to n is equal to 10. Therefore, 3 raised to n is equal to 9. Therefore, 3 raised to n is equal to 3 square. N is equal to 2. Let's check here. 1 minus x raised to n is equal to 1 minus 3 raised to n is equal to 10 minus 3 raised to n is equal to 9. This is not possible. Now I have got n ka value as 2. Since I have got n ka value as 2, my function, I know that my function is f of x is equal to 1 plus x square and finally f of 4 ka value will become 1 plus 4 square which is equal to 17. If you know, you already got this सबसे पहले when you read the question. f of 3 is equal to 10 कब possible है? 9 plus 1 मतलब 3 square plus 1 मतलब 1 plus x square. You can directly solve this also without doing the whole step. This is given. If you can crack this, you reduce your time by 95%. कुछ नहीं करना है सिर्फ. You have got 1 plus x cube, 1 plus x square, सीधा 4 डालो, you have got the value 17. You can solve the sum under 10 seconds. But you have to be very careful. So that this is the actual flow of the sum. And this is the shortcut where you can directly substitute the value and you get the answer. Please write this.